our planet. We have a great capability to absorb, interpret, and comprehend, and an urge to understand the world we live in. This is what defines us as human beings, what makes us who we are. With our technological advancements, we are now capable of exploring new worlds, new frontiers. We're searching for answers that may lie in front of us. Better yet, above us. The field phase of the experiment is about to begin. All the planning, sleepless nights, meetings, and hard work the team has invested in the mission are at stake. My name is Yasna Pittman, and I'm one of the many scientists working on the airborne tropical tropopause experiment.
It's very natural for humans to want to understand how the world around us works. Why the atmosphere does what it does. It's like solving a puzzle.
You just want to understand how it works.
We're trying to understand how humans are affecting the atmosphere.
Understanding how the stratosphere changes very much reflects how our climate is changing. I think that the work that is done in atmospheric science is very important, but it's also a lot of fun. It's like the best job possible. Well, NASA has been doing airborne science investigations for quite some time. Some of the earliest investigations we were doing was related to the early days of the Antarctic ozone hole. In 2009, we started a new kind of program. It's called the Earth Venture Program. It's got 3 parts, and the first of those parts is what we call suborbital science. This is science done not use a new satellite. With some of these newer missions, he has their own way of implementing the mission, what their own science requirements are, and they bring their measurements to the table. And ATREX had very good science, was very relevant to the kinds of questions we wanted answered, and its budget was reasonable and appropriate.
So ATREX is an airborne campaign to try to understand how stratospheric water vapor affects climate.
It causes perhaps maybe 15 to 20% of the warming that we've had in the past 15 or 20 years.
So it turns out that small changes in the humidity of the stratosphere are very important for climate, important for surface temperature. They're actually comparable to the importance of greenhouse gases that everybody knows about.
So, for example, we know that if you go back 30 years, carbon dioxide was quite a bit less 30 years ago. Methane was less quite a few 30 years ago. Nitrous oxide was less 30 years ago. So we know these gases are increasing with time.
Gases that affect the chemistry of the stratosphere, which is where the ozone layer exists that protects us from ultraviolet radiation.
So understanding the rate of the atmosphere and how it changes the climate of the stratosphere and how the stratosphere climate affects the lower atmosphere.
So we really need to understand what the of the stratosphere and actually be able to predict that in the future in order to improve the accuracy of our predictions of future climate.
That goes on in the upper atmosphere